of the first two together? Do they have anything in common when they're put together? X to the what power? X to the third, and then what else should I probably take out?
Y.
How many y's? Okay, and then there's one more thing I want to take out.
-1.
I want to take out that negative sign. I'm not even going to write the one. Okay, what would I be left with? Y to the fifth. Minus 10 to the what? Is it 10x to the third? David said. Is that correct? No. What should it be? Okay, and then there's something else wrong in what I've written as well. It's an easy fix, though. It should be a plus sign. When we factor out a minus, they were both minus, so they should both be positive then. Okay, so we factored in the first group, and the one good thing about Grant not being here is I can use colors. What can I factor out of the second group? A -9. And then I would be left with what? Y squared. And then what else? Okay. Okay, now this looks completely like gibberish, but this is what they'll ask you to do in Algebra 2 with trig. They're going to ask you to do a few more steps after that, but if you follow that factoring, then we're good to go. Is that what we've been doing lately? No, we've just been factoring out the greatest common factor, which is y in the first period. All I wrote was negative everybody. X cubed, y to the 6th, plus 10, x to the 4th y, plus 9, y squared, minus 9. That's all I did in first period, because, let's face it, the first period has me early in the morning, so it's a little bit more of a struggle. Okay, I would love an answer to this second Mower question today. If I were going to guess, which two would I guess? Why would I guess B or C? They both have 8s. I'm always looking for a pattern. Can you tell me how you set up and solved and got C? Okay, so this is what someone did in first period. They said take 300,000, divide by the 10,000, and you get 3 million. They said 3 million times 295 is 8,850,000. Why am I happier with Danny's response than with their response? Because we've been learning about proportions, so of course I wanted to see an actual proportion set up where you cross multiply and everything. When you cross multiply and you solve, you do end up getting C. But I'm happier with what she did. She shows me she understands what we've been talking about lately. Are there any questions on the bell ringers? Okay, then take out your new notes for today. There is only one teeny tiny problem with what we're doing today, and it's my fault. Well, it's life's fault. It has to do with Chapter 5. In Chapter 5, in Section 1 and Section 2, we were in a hurry because we were behind, because I feel like we're always behind, because it's just life. Because we had weather days and stuff this year, and we're a little goofier this year than we were last year, so we're just not quite as far along as we were. Anyway, long story short, in Chapter 5, we skipped some stuff. We did. We didn't do any problems involving altitudes or medians. We've done problems all year involving angle bisectors. Did we talk about an altitude? Yeah, because I made you learn orthodontist makes you say ah, and I made you take a little vocab quiz on it. Or like medians happen in the center of the highway. We talked about medians and centroids. So we've talked about these things, but we've not actually done problems with these two before until today. So that's one teeny tiny problem. It's not a big one, as long as you can identify them. So an angle bisector, I swear, I'm not going to cry. I would probably scream if you didn't know that an angle bisector cuts an angle in half. Angle in half. So looking at our 3 examples below, 1, 2, and 3. Don't, Elena. Is 1, 2, or 3 an angle bisector? Anyone but Elena can answer. She's out. For all day today. She's out. Not useful. Good. Is 1, 2, or 3 angle bisectors?
Oh, I got you.
Why?
Because they want to help.
Okay, as long as we can identify them, I'm good to go. Perfect. So angle bisectors are easy to spot. Medians are also easy to spot. The way an angle bisector cuts an angle in half, a median cuts a side length in half. That's why those two sides have markings, because they're congruent, because it cuts it in the middle. So, looking at our 3 examples, is 1, 2, or 3 dealing with medians? 3. 3 is with medians. Okay, Danny, I don't need you to answer anything else today either. And then, so medians, I would think center. And then if I'm needing a little trick for altitudes, notice that they have a right angle. It's going from a vertex to the opposite side, and there's a right angle. Obviously, number 2 is going to be the one dealing with altitudes. Okay, and you're probably going to say miss something, because once we start doing these problems, you're going to realize that never once does it say, Tilly, is this an altitude, an angle bisector, or a median? It doesn't say that, no. But the way there was a trick on the last test, and one of the problems were not similar, they could trick you in this case. They could make it look like something. It needs to either be an altitude, an angle bisector, or a median to do the magic math we're about to do. If it's not one of these 3, you can't do the magic math. So do I identify it first? Yes, I do. Do I trick you often? No, I don't. Okay, so remind me what makes shapes similar. There are 2 things that make shapes similar. What's the first thing? Two things make shapes similar. You need 2 things. What's the first thing?
To make a shape similar?
Mm-hmm. The angles have to be what? The angles have to be congruent. So you got tricked on the last test. There was one problem where the angles were not congruent, so they weren't similar to begin with. I believe it was the last one. Okay, and then what's the other thing? What about the sides? What are the sides? Are they congruent? Then it would be congruent figures. We're not talking about congruent shapes. We're talking about similar shapes. That would be a silly answer. I'm not needing silly answers. What are we doing right now? What are we doing right now?
I don't know.
Then stop answering questions. What are we doing right now? What have we been doing for like the past week and a half? Proportions. The sides have to be proportional. And when you calculate that proportion, Joshua's right. It is called the scale factor then. Thank you, Elena, I assume. Okay. So, if you have those magic things, and you're already told your shapes are similar, because it says are similar, so that you're told in the directions these shapes are similar, then automatically the altitudes are proportional to the sides, the angle bisectors are proportional to the sides, and the medians are proportional to the sides, meaning I can do some magic math. So I can do x over 8. Oh, I'm not going to do x over 8, sorry. I've done it the same way every single time. I'm going to be consistent today. I'm going to do this shape for one fraction, and this shape for the other fraction, and I'm going to cross multiply and solve. So if I do x over 15, then what do I need to put in my other fraction? 8 over 12. Make sure x and 8 are together. Make sure 15 and 12 are together. You cross multiply and you get what? So x equals, awesome. Awesome. Are there any questions on number 1? Then I need someone from Sabby's group to set up number 2. Thank you, Isaac. Isaac said x over 15 and then 16 over 20. You could have done 16 over 20 equals x over 15. Heck, you could have flipped it and had 20 over 16 equals 15 over x. When you cross multiply, you get 20x equals, I don't know what that number is. So x equals 12. And then we get to our last example on the top. I need someone from Sawyer's group to set up the last one. No, you're not in Sawyer's group. Thank you. You cross multiply, you get 9x equals something. So x equals 4.5. We're great with decimals right now. Not a problem. So, even though you don't remember what an altitude or a median is, you should. You for sure know what an angle bisector is. Regardless, if you're told in the directions that the shapes are similar, which is what we were told, then you still just get to set up normal proportions, cross multiply, and solve. So again, if you can't set up proportions, show me your work, cross multiply, and solve, we got an issue on this section too. Okay, so we only have one new thing to learn after this, and then that's all there is today. You get to practice the back. That's it. It was an easy day. The last thing we have to learn is it's a theorem. I would put a star by it. It is the triangle angle bisector theorem. It says if you have an angle bisector, which we do, because it's cutting that angle in half, then you can still set up a proportion with Km and Kj in one fraction, and Ml and Jl in the other. Okay, so I need someone to help me set up number 5. We're going to say 4 for a second. I need someone to help me set up number 5.
X over 4 equals 13 over 6.
Perfect. X over 4, you got it from the one triangle, or part of this one giant triangle, part of the triangle. You got it from the other part of the triangle, 13 over 6. Notice x and 13 are together, 4 and 6 are together. You cross multiply, you get 6x equals, so x equals, I'm going to put 8.67 then. I'll allow you both now. Why did I say 4 and 6? Why did I do 5 first? What makes it easier than the others?
Because we have to type something.
Okay. Okay. What am I going to do about this missing piece? It's got nothing on it and I need something. Because I'm wanting to do x over 14 equals whatever this is over 11 and cross multiply and solve, but I don't have anything on that piece. Divide by 2 would make sense, but then we're saying that it's going to be like 10 and 10. Was this 5 and 5? Look at number 5. Was it split in half? No, it was 4 and 6. So how do we know for sure it's going to be half and half? We don't. If I told you x was 3, how big would that gray piece be? Okay, if I told you x was 12, how big would that gray piece be? If I told you that x was 16, how big would the gray piece be? How are you figuring that out? You're subtracting what? Say it, Nick. You say it, Nick.
Whatever you said.
From? Okay, so you had 20. We're going to subtract whatever we say x is. So I'm going to put on that missing piece of 20 minus x. So if this one's 17, then that one's 3, because 20 minus 17 is 3. If this one's 10, well, 20 minus 10 is also 10, so that one's 10. This way it's going to work out every single time. Okay, so now I can finally set up my proportions, because everything's worked out. I'm going to do x over 14 equals 20 minus x over 11. When I cross multiply, I get 11x equals 14 times 20 minus x. Thank you. Again, Eric's going to mess up if he forgets to distribute that 14 to both the 20 and the x. He adds 14 to both sides. He has 25x equals 280. So he ends up getting x equals some number. Okay. Are there any questions on that one? Now I need you with your group to try the same sort of logic on number 4. Shout out your answer when you have it. Okay, if you get 5.4, you can flip over your paper and move on. If you don't get 5.4 in about 2 minutes, I'm going to show you my work. Okay, if I didn't call out your name with that giant list and you fixed your 7-4 worksheet, bring it to me, I'll gladly check you off. If you finish your 7-5 worksheet and you want me to check it, bring it to me.